The law of sines is not a cure-all. You do have to be careful because of the angle side-side scenario. If you recall when we were doing proofs, angle side-side can lead to an ambiguous case. I'd like to draw that out for you to make sure you understand what I'm referring to. If I have a triangle where I have an angle that has been given to me, say it was 40 degrees, angle, side, let's say that this was 19, I have to worry about where this other side falls. Because if this is, say, well, let's do a right triangle first to explain it that way. If I drop this down as a right triangle, there's only one triangle that would exist, right? But the length of this, if it's longer than what that height would have to be, so this would be the minimum distance from this side down to the base. That's a minimum distance, that's a right triangle. If it's longer, I could be creating two different triangles. I could have a triangle that's running this way, which if you look at that, that's clearly an obtuse triangle, or it could be running this way. If you say, I'm not following, I don't know how long this base is down here. This base could go as long as I need it to be. So if this runs all the way over here, if you look at where my pen is running, that would be an acute triangle. So this is known as the ambiguous case. If you give me an angle side-side, I may not know which triangle I'm working with. And so the law of sines would not help me here. And let's say that this was 15. I don't know where that's falling, if it's an obtuse triangle or an acute triangle. The law of sines will not work for me. Now there is an exception to this. If I'm starting off with an obtuse angle here, say this was 105 degrees, and I go angle side-side, I can simply use the law of sines to find everything else. Why? Because I know it's an obtuse triangle. I don't have to worry about this scenario. So if they tell me that this is 13, see, here's my angle, side, and I run this out like this, and I tell you that this is 24, I should be able to find the missing side over here, or the angles for that matter. And how would I do that? We'll walk through that here as our second example. Let's call this triangle X, Y, Z. I think in this situation, it would be in my interest to find this missing angle right here. So I'm going to start with my angles on the top. And so I'll say sine of 105 degrees. Now the 105 goes with this big side here of 24, which would equal sine of angle Z over side 13. See, Z went with the 13. Now to solve this, we had talked about this briefly, and so I definitely want to take my time and explain this to you. I want to solve for sine Z. Sine Z equals, I can simply bring that 13 up. So it'd be 13 times sine 105 over 24. But that won't be the angle Z, it would be the sine of angle Z. So I will have to then undo the sine. To undo the sine, I will arc sine both sides. Now I like to put everything right in my calculator, so I do as much pencil work as I can, paper work as I can. I'm going to say arc sine of Z. What you do to one side, you must do to the other. So this would be arc sine of all that goodness that I have typed there. 13 times sine 105 over 24. Now I'll let my calculator do all the work here. So turn the calculator on. I'm going to do the arc sine, which is simply going second sine 13 times sine of 105, close that angle out, divided by 24. And I'll close the parenthesis so you can see that. I am in degree mode, so everything's good. I did arc sine of 13 times sine of 105 divided by 24. Now I hit enter. That gives me an angle of 31.548 degrees is equal to, now on this side, when you arc sine a sine, those cancel out. You'd just be left with angle Z. So I now know that this angle is 31.548. To find the other angle, I know that there's 180 degrees in a triangle. I don't have to walk through this process again. I simply take my 105 plus the 31.548, and I'll subtract 180, making the answer positive. The other angle is 43.452 degrees. And if I want to find this missing side, well, that would be easy enough to do because now I have this angle. And I suppose I should just run through that. I'll go ahead and run that through that right here. So what I'm going to do is work with my known information. Now this time I'm looking for a little x. I'm looking for a side. So I'm going to start with the side on the top. I'll say this. I'll say 24 is to sine 105 as, and now because I'm looking for that little x, I can say x is to sine 43.452 degrees. And then because I'm just trying to solve for the x, I can bring all of this up. As I bring it up, I can say sine of 43.452 degrees times 24 over sine 105 equals x. And once again, I just go to my calculator. It's a lot of calculator work. So I'll type in sine 43.452, and then I'm going to multiply by this fraction of 24 divided by sine 105. And you can see how I just use those proportions to my whim. I put them the way I want them. Sometimes I have the side on the top. I'm just consistent with that. Sometimes I have the angles on top. And I hit enter. I get 17. X is equal to 17.088 units. And that's how you use the law of sines.